And now, for the moment you've all been waiting for. Perfect square trinomials application. Sorry, man, I shouldn't have did this. That's ridiculous. What we're going to do in this video is I'm going to show you how to use those perfect square trinomials. Did I write that sticky note down anywhere? No, but oh, yep, I did. We're going to use the perfect square trinomials, this part down here, in order to solve a quadratic equation. And this is weird. You might have to do this, but you can probably just use the quadratic formula if you want. This will apply whether or not it factors. All right, doesn't matter if it factors or not. You can always do this. This is another method, and it's called completing the square. What we're going to do, you know how I told you it's illegal basically to add this magical part where you cut this in half and square it? The way that you can get around that is just add it to both sides. If it's an equation, you can do that. All right. So I'm going to, okay, I'm just going to do it like this. I'm going to go ahead and cut this in half. That's that part. And then square it. So half of 8 is equal to 4, but then I'm going to square that. So 16, I'm going to add that to both sides. So plusing 16, x squared plus 8x plus 16 plus 8. Oh yeah, I do have to be careful. Yeah, plus 16. What I need to do actually is I need to move this one over to the right side. I haven't done this in a while. Sorry. So I should have did that at the beginning probably. All right, x squared plus 8x plus 16 is equal to 8. All right, so that's what I should have done earlier. Now this side is going to factor. Two numbers that multiply to 16 and add up to 8, well, that's 4 and 4. Or the trick was just to, keep that sign and then cut this middle one in half. So x plus 4 squared. So that factors. And then on the right side, we have an 8. Now this is definitely solvable. You're going to square root both sides. So you're going to get x plus 4 is equal to, because the square root and the square cancel, is equal to plus or minus root 8. And now you can just subtract 4 from both sides. So x is equal to negative 4 plus or minus root 8. And that is your answer. All right, it's an irrational number, but we still were able to do it. You couldn't do that with factoring. You could do it with a quadratic formula. But, you can make these into a decimal if you wanted to. Negative 4 plus root 8. All right, is that negative 4 minus root 8? Is that? Okay. Let's do it one more time here. So first thing I need to do, I'll learn my lesson here, is I need to move this 7 to the other side. So let me just, 2x squared plus 18x is equal to 7. Now in this one, it's a little different because you'll notice here it has a 2 attached to it. So you're gonna have to do something else too. On all these that we did earlier, it was all just a 1x squared. And there's 2 ways to handle this, but I'm just gonna do the most straightforward here. I'm gonna divide both sides by 2. All right, it's an equation, so you can do that. This is going to become x squared plus 9x, and I'm going to leave me a little space there, is equal to 3.5. Yeah, I'll just leave it in decimal form this time. I could do it as a fraction, but all right. Complete the square now because that's a 1. Half of 9 is 4.5, and then 4.5 squared is 20.25. So we get 20.25, but we have to add that to this side as well. 20.25. And now we can go ahead and factor it. It's going to be x plus, and then half of that middle term. So 4.5 squared. Remember, that's that little trick that we used here. You just take half of the b term, all right, and that's how we got the 4.5. And then on the right side, we're going to get 23.75, and this is going to be hideous. So I'm going to leave it in hideous form. We're going to square root. You're going to get x. I'll just write it out. 4.5 is equal to plus or minus square root of this. And now you'll subtract the 4.5 from both sides. So x will equal negative 4.5 plus or minus all of that. Good. That's it for that. Boy, that was ugly. That last one was. But that can be used instead of the quadratic formula even.